What will we learn in this episode? Have you ever wondered what really happens to a road when the skies open up? When rain falls faster than the city can breathe? And when millions of liters of water attack the pavement from above, below, and every side? Most people see rain as a calm, peaceful moment. But engineers see a silent battle, a battle that determines whether a road will survive or collapse. You are watching episode 3 of our special series on road construction in extreme climates. This episode takes you deep into the monsoon zones, regions like the Western Ghats and Northeast India, Sri Lanka, Bangladesh, Indonesia, the Philippines, Malaysia, southern China, Japan's Pacific coast, and parts of East Africa and South America, places where relentless monsoon rains push both materials and design to their absolute limits. In this episode, we explore the fascinating hidden world beneath our roads. A world filled with channels, filters, reservoirs, fabrics, stones, and technologies that quietly fight the monsoon every single year. We will see how cities manage stormwater, how parking areas survive cloudbursts, how porous pavements drink rainwater, and how expressways remain safe even in the heaviest downpour. And finally, we will end with a small glimpse of the next episode, where we climb into the dangerous mountains, where rain, slopes, and geology create engineering challenges like no other. So, let's begin our journey. Every structure has a story. Every road, every bridge, every foundation begins with an engineer who dared to understand the unseen. Welcome to Civil Guru Solutions, where we uncover the hidden science behind the world you walk on. From design to surveying, estimation to execution, and quality control, we take you deep into the heart of civil engineering. Our mission is simple: to turn complex engineering knowledge into clear, practical learning for students, professionals, and dreamers across the world. Our videos are available in English, Spanish, French, Portuguese, Arabic, Hindi, Tamil, and many more. Learning has no borders here. Select your preferred language directly through YouTube's audio settings. If our content inspires you, support us by liking, sharing, commenting, and subscribing. Civil Guru Solutions, where learning becomes an experience. Let's build the future, one lesson at a time. What makes road construction in rainy areas so challenging? When the monsoon clouds gather, when the sky turns into a silver curtain, and when millions of raindrops strike the ground every second, a road begins its greatest battle, a battle against water. To a common person, rain feels refreshing. But to a civil engineer, rain is the most unpredictable enemy, because every drop of water tries to weaken the road from every direction. From the top, from the sides, even from deep beneath the soil. This is why engineers across the world live by a rule that sounds simple, but carries a lifetime of wisdom. Drainage first, pavement next. For without drainage, even the strongest pavement becomes helpless. Why do roads fail faster when it rains? To understand this, imagine the soil below a road like a sponge. When rainwater enters this sponge, the soil swells, loses strength, and can no longer carry the weight of the road above it. Cracks appear. Water enters deeper. The base softens. The pavement begins to deform, and potholes are born. This is not an accident. This is physics, and every engineer must respect it. So before we talk about construction, we must first understand water, how it travels, how it collects, how it destroys, and how we can defeat it. How do urban areas handle stormwater? A city is a forest of concrete, a place where natural soil is covered by rooftops, pavements, tiles, asphalt, and buildings. And when rain falls on these hard surfaces, it has only one desire: to escape quickly. But escape where? That is where stormwater management begins. Urban stormwater systems are designed like a hidden nervous system below the city. Rain falls, water flows across roads, enters collection chambers, travels through pipelines, and is finally released into rivers, lakes, wetlands, or the sea. It is a continuous journey. To keep a city alive during monsoon, Three powerful systems work together. 1. Surface drainage guiding water across roads. 2. Subsurface drainage collecting water below ground. 3. Underground stormwater pipelines transporting water away. 4. Detention ponds and wetlands holding water temporarily. When all these systems work together, a city survives the monsoon with grace. How many types of stormwater designs exist? Stormwater systems can be beautifully grouped into three major families: parking areas, roads, and wetland-based detention zones. Let's explore them one by one as a story. 1. Parking area stormwater design. Parking zones receive enormous sheets of water. A single heavy rain can flood an entire commercial parking lot within minutes. To protect these areas, engineers create a combination of permeable pavements that drink water, porous asphalt that allows water to flow through, bioswales shaped like natural streams, perforated pipes hidden below pavements, detention pits that temporarily store water, and wetland ponds that purify water before releasing it. Here, the engineering feels almost natural, as if the rain and the pavement are working together. 2. Road stormwater design. Roads are shaped with a gentle camber, like a shallow roof. As rain falls, it instantly flows sideways, rushing into drains placed at carefully calculated intervals. Indian Roads Congress recommends a slope of 2.5 to 3% for bitumen roads, and even higher for cement roads in heavy rainfall zones. Catch pits, curb openings, cross drains. Each one is positioned like a chess move. The road's mission is simple: remove water before water removes the road. 3. Wetland-based detention systems. When cities grow, natural absorption reduces. This is why many modern cities around the world, from Singapore to Seattle, build beautiful detention ponds, constructed wetlands, and sediment traps. These are not just engineering systems. They are ecological masterpieces. They slow down stormwater, filter mud, recharge groundwater, and protect the city from flooding. Nature and engineering working together. How do permeable and porous pavements work? Here begins the real magic of modern road technology. Instead of fighting rain, these pavements invite rain. They allow rainwater to pass through them, like water through a sieve, down into the layers below. There are three main heroes: porous asphalt, permeable concrete, permeable interlocking pavements. Let's explore them with cinematic clarity. Type 1. Porous asphalt pavement. Porous asphalt looks like normal asphalt, but it hides a secret. Its structure has millions of tiny interconnected air voids, allowing water to flow freely through the pavement, disappear into a stone reservoir, and slowly seep into the soil. Underneath the asphalt lies a perfectly designed system. A filter fabric acts like a guardian, letting water pass but blocking soil. A stone recharge bed stores the rainwater temporarily, holding nearly 40% of its volume as voids. A porous asphalt base layer carries the load while allowing water to travel downward. A finished course of open-graded asphalt completes the surface, strong yet breathable. This modern pavement can drink thousands of liters of water within minutes. It reduces surface flooding, prevents hydroplaning, and supports groundwater recharge. A beautiful example of sustainable engineering. Type 2. Permeable concrete, filtercrete. Permeable concrete, commonly called filtercrete, is a bold innovation. Unlike ordinary concrete, this has almost no sand. It is made of cement, water, and small aggregates bonded together, leaving large open pores. Rainwater pours through it instantly, like water falling through stones. It is perfect for parking areas, footpaths, low-speed residential roads, and pedestrian plazas. The mix itself is an art. A carefully controlled water-cement ratio, special admixtures to improve flow, zero fines to maintain large voids, and a curing method that avoids water using sheets that trap moisture inside. It's simple yet futuristic. Strong enough for parking loads and friendly enough for nature. Type 3. Permeable interlocking pavements. These pavements look ordinary, colorful tiles locked together. But what lies below makes them extraordinary. Rainwater slips through the joints, flows into a bedding layer of fine stone chips, enters a sub-base of large aggregates, and finally reaches a geotextile protected drainage zone. A perforated pipe hidden below quietly collects excess water, carrying it to stormwater channels or manholes. This system is widely used in advanced cities because it is flexible, attractive, and environmentally friendly. Some designs even include small vegetation patches, blending nature with engineering. Why are artificial pebble streams and bioswales used? In many landscape parking zones, rainwater is guided into beautiful artificial pebble streams. These pebble channels serve multiple purposes. They slow down water, filter impurities, support plants, create a cooling effect, and add scenic beauty. This concept is part of global sustainable engineering known as Low Impact Development, LID. Sustainable Urban Drainage Systems, SSUDS. These systems keep cities beautiful, safe, and environmentally responsible. How do highways and expressways survive heavy rains? Urban roads fight rain. Parking areas manage rain. But expressways must dominate the rain. Millions of vehicles, high speeds, long stretches. Here, even a few seconds of water accumulation can cause hydroplaning and fatal accidents. So expressways use a highly advanced drainage system. The asphalt itself is engineered with controlled air voids. Below it lies a drainage layer, a foundation of aggregates that guide water away. Wet mix macadam layers provide strength and prevent saturation. Geogrids improve soil stability. Subsurface drainage layers, known as SSDL, form a network of pipes and stones that quickly evacuate water. On the sides, French drains run silently, collecting stormwater and carrying it to chambers and manholes. Vegetation or stone pitching protects slopes from erosion. Everything is perfectly coordinated, like a symphony. The goal is simple. The road must remain safe. Always. At any speed. What are the benefits of these modern systems? When a road is built with intelligence, it transforms the entire city. It becomes eco-friendly. It reduces flooding. It removes standing water. It allows groundwater recharge. It reduces infrastructure cost in new developments. It reduces the need for large retention ponds and increases the usable built-up area. And most importantly, it extends the life of the pavement for decades. This is engineering not just for today, but for the future. What should we remember before ending this episode? Stormwater management is not a small chapter in road construction. It is the foundation that decides whether a road survives or fails. When drains are designed well, when pavements allow water to breathe, when nature works with engineering and not against it, roads become stronger, safer, and more sustainable than ever. This is the new era of civil engineering, an era where roads do not fight the rain. They outsmart it. In the next episode, we will climb into the most unpredictable terrains on Earth, the mountains. Landslides, cloudbursts, unstable rock formations, vertical cliffs, and engineering decisions that determine whether a road lives or dies. If you want to understand how roads survive in such dangerous places, from the Himalayas to the Western Ghats, don't miss episode 4. If you found this episode insightful and you want to learn the hidden secrets of civil engineering, subscribe now and stay tuned for the next cinematic chapter. The journey continues.